tell you how this is going to work. You've been instructed to prepare roughly a 15-minute presentation. That's 15 minutes from beginning to end with no interruptions. But we reserve the total right to interrupt you anytime we want to. We will ask you a question if it comes up in the middle of the presentation, and don't worry about that. We would much rather have that rich discussion than worry about time. If we decide not to interrupt you as it's going, we'll save all our comments and questions for the end. And then we'll just chat as long as we need to. Okay? So the idea of this whole process is for you to get as much feedback as you can and to incorporate that feedback into improving your plan as you're moving forward. That being said, I hope there's more than one person taking notes on what's going on here, and try to try to capture every tidbit of information that comes out, because you probably will find a way to use it. Okay. So one thing I strive to do in these proposal defenses is probably one of the first times, if not the first time, you've been in this exact kind of a situation. But if you stay in the research science world, you will be in this situation many times in the future. It's very important for you to know who you're speaking to. Not necessarily personally, but know what their background is, what their level of expertise is, so you know how to pitch your presentation. If you're at a professional conference and you have an auditorium full of 500 people, you're not going to know each and everybody there and know what their background is, but you're going to have to get an idea beforehand of where to craft your presentation and where to aim it. So if it's an auditorium full of highly technical, trained folks who have been working in the field for years, you aim it here. If it's an auditorium full of more of a lay audience, you aim it at a different level. And if you're in a room and you're trying to impress people who are in the business sector or the NGO sector, and you want them to give you money to support whatever endeavor you're trying to propose, you have to aim in a different direction. Okay? So to kind of drive that point home, we're going to go through an overly formal process of formally introducing ourselves as your audience. And then as you launch into your presentation, I'm confident you will introduce Team Armit to us. So why don't we start here with this unknown gentleman, and he can introduce himself to you.
Okay, I am Anil Dean. I am the mentor for this project, and also I have a lab that supports this project in some ways. And I'm just generally going to not say much because I've been asking them a lot of questions all of their time with me. So,
Okay. Very good.
but I still reserve the right to ask.
Of course you do. That's why you're here. I'm Dr. Frank Cole. I'm a professor in environmental science and technology. My specialty is studying the soil. I'm also, as you know, the director of the Gemstone Honors Program, which is a really fun job to have. And I'm looking forward to learning more about your controller and how it's going to work. Shit, bear with the voice. Want me to interpret?
Joshua, describe who I am.
This is Muma Zhu. She is a professor in aerospace engineering. She's mentor for various student teams around campus. Maryland UA, including Maryland UAS and the Counter UAV program.
So I do work in autonomy and controls, so you can talk technical to me.
Okay, good.
Not to me. My name is Kristen Scandell, Associate Director of the Gemstone Honors Program, and my expertise is around leadership and teams, so I'm less on the technical end, but you've done a nice job explaining everything in your proposal.
Hi, I'm Selena McDonald, resident librarian, I guess. I worked with them because I work with a lot of government information, government documents and law things, so I thought this would be a good team to kind of.
Good. And I will say, Josh, I directed this towards you, very clever strategy having a reviewer who can't talk. Come to your defense. Well done, well played.
I'll just say everything for her, right?
Brilliant. I've never seen such a brilliant move. Okay, and with that, floor is yours.
Hello everyone, thank you for coming. My name is Colin McNulty, this is Joshua Gauss and Jin Cheng Lee. We represent Team Armit, a multidisciplinary undergraduate research team in the Gemstone program here in Maryland. This is our proposal meeting where we will be proposing our project to integrate emerging commercial technologies into UAVs for the purpose of search and rescue. Disaster areas are dangerous by their very nature, both for the initial victims and for any rescuers who enter the area to help them. UAVs offer the unique capability to allow rescuers to search the area without their actual presence, which reduces the overall danger of the situation, both by keeping them in a safe area and by removing the possibility that their presence will destabilize the wreckage and cause additional harm. Currently, the application of UAVs in search and rescue is experimental. Most commonly, there will just be a commercially available drone such as this that is owned by a local hobbyist who volunteers their time and their private platform to search an area and simply relay whatever they find to the actual rescuers. There's little to no standardized or specialized UAV system specifically for search and rescue. Our project proposes to design such a specialized UAV system specifically for search and rescue. Our most important improvements can be categorized in 3 points. First off, we would like to integrate a head tracking system to control the camera. In this way, the user will be able to intuitively aim the camera by turning their head the way they have their entire life. And in this way, the operator of the UAV will be able to survey a larger area under the UAV without compromising the motion of the vehicle. Second, we would like to design a stereoscopic camera system because we believe the stereoscopic vision will give the operator significantly improved depth perception, which will vastly improve situational awareness in these close to the ground disaster areas we plan to specialize this drone for. Third, we intend to design a series of virtual and augmented reality overlays, which will be placed over the video feed from the UAV to provide the operator with additional information about the environment and the mission, such as indicating which areas have and have not been searched already, or a last known photo of who is being searched for so that they can be more readily identified. This is a rough mock-up of our system with all its components, including the stereoscopic camera gimbal and the head-mounted display connected to the ground computer. This leads us to our 3 research questions. First off, how can stereoscopic vision improve UAV operations? In other words, does the added depth perception improve the piloting of the UAV? Second, how does a virtual reality and augmented reality video feed affect operator visualization of scene? In other words, how much can situational awareness be improved through the addition of these virtual and augmented reality overlays? Third, how can a virtual and augmented reality interface improve on existing search and rescue methods? Or, in other words, how can the search and rescue process be made more efficient through the integration of these virtual and augmented reality interfaces?
So to answer those research questions, we plan on constructing a system consisting of a payload and ground control station. As you see in our rough mock-up here, the payload section will consist of a gimbal and a camera. The camera system we plan on using is 2 GoPro Hero cameras and a custom-built gimbal that controls the camera. And those 2 GoPro cameras will feed a stereoscopic video feed to the ground control station, which will add an overlay, and then through that, display it in a head-mounted display. We choose the Oculus Rift as our intended head-mounted display because of its familiarity and its programmability, also because it comes out first. We've already began construction, small steps, of this system by using the lab that Dr. Dean has allowed us to use. For example, we've constructed a stereoscopic acuity test to initially gauge our first research question: is stereoscopic vision better than monoscopic vision? So this test is the proper name is the Howard-Dolman test, but basically what it does is it lets the user attempt to align two objects, in our case in a virtual space, and we will let them align it both in monoscopic and stereoscopic vision, and compare the two results. Another test, another progress I should say, that we had was, as I said before, we needed to have a stereoscopic video feed go into the ground control station, but we had two GoPro cameras with two separate video feeds. So to combine those two video feeds into one, we used a program called OpenCV. And what OpenCV does is basically take various video streams and combine them into one. As you can see here, this is a stereoscopic image that we've taken in our lab, combining two separate image feeds. Another test that we plan on conducting is called a GoPro latency test. So the Oculus Rift recommends a latency, or delay basically, of a maximum of 20 milliseconds. That's not a lot. So we want the GoPro camera, we want to know if the GoPro camera can stream the data with as less delay as possible. So we're going to test the GoPro camera's streaming capabilities at various ranges. And what you see in the numbers to the right there will be examples of what the data we will have. Basically, what time the data will arrive in the ground control station compared to when they were sent. This past Saturday, actually, we conducted a flight test for a commercial usage UAV to familiarize ourselves with the controls of the UAV. What you see here is a video taken by the camera on the UAV itself, streamed live to a mobile phone.
So you may want to point out that the first flight test of this was done inside a building.
Yes.
Because the flight outside is very restricted, and we're in very restricted airspace.
So
we're going through that process. Go ahead.
Since we're near Washington area, basically everywhere near this region is a flight restricted area. So unless we're a hobbyist, which we're not, we're a research team, we have to get licensing in order to fly outside. So we kind of bypass that by testing our flights indoors.
The first flights, but the subsequent flights, and there's a plan.
And we will
for
mention
getting all
that.
that.
Yes, we will.
So, yeah, you mentioned it.
So these are just a few initial tests that we're doing as we're starting our project. We have many more laid out for the future. To go over some of the larger tasks we have in front of us, the most work-intensive one is building the gimbal payload. So a gimbal is just a device that aims a camera in different directions. You can see the one here on this UAV uses brushless motors to keep the camera steady as the vehicle rotates. It can also rotate the camera independent of the vehicle. Most gimbals mount one camera. We intend to mount two side by side so that the user can get two feeds, one for each eye, to enable stereoscopic vision. In addition, on the software side, we are going to develop overlays, as Colin previously mentioned, to interpose additional data on those video feeds from the stereo cameras. This could also include conventional data such as the altitude, the route of the vehicle laid out so that it's very easy to follow, signal strength of various transmission and receiving components. One of the major challenges that we've come across in this project is data transmission. So VR video is very data intensive. A full-size VR video feed for the upcoming generation of, first generation of VR headsets, such as the Oculus Rift HTC Vive, is about 7.5 gigabits per second of data in video form. For comparison, a full-size 1080p 60 FPS stream, similar to what you would watch football on, in your living room is 4.5 gigabits per second. The various techniques available to do this are purpose-built links that can handle the 1080p 60 FPS standard, but cannot handle the larger size VR video feed, and attempting to stream the video over a Wi-Fi system, which has a much smaller data throughput. This smaller throughput means we would have to compress the video, which would add an unknown amount of latency to the transmission. So we'll have to determine which method is better or come up with a third method in order to complete our project. Additional tests that we would like to do are a full software mock-up of our intended platform. We will modify an existing UAV simulator to output a video feed from the simulated UAV over the Oculus Rift and use the same input methods that we would on the actual prototype so that we can test the whole system virtually before we test it physically. This will also allow us to test volunteers on various different configurations of the system to determine which one is best for actual use. We also concurrently will build a physical prototype of our system. Hopefully we will be able to test it at a National Institutes for Science and Technology test center where other UAV tests are completed. This way we can compare to existing systems. We would like to thank the Institute of Physical Sciences and Technology and our mentor, Dr. Anil Dean, for providing us the use of Dr. Dean's lab space, as well as an initial commercially available UAV for familiarizing ourselves with the technology, and ample computational resources in the lab to complete our project. We've also compiled an initial budget and a timeline for the various tasks. As you can see here, we have flight simulation testing, which I previously went over, in fall of 2016, finishing a physical prototype by spring of 2017, with NIST testing hopefully completing shortly thereafter. Thank you for your time. Are there any questions?
Okay, nice presentation. Good summary. I think it captured the essence and the message of your proposal very well, which is sometimes hard to do in a brief presentation. We have a tradition of starting questions with our outside expert, but you want to whisper and I'll translate, or we're all really quiet, but don't want to distract your voice.
Like one at a time?
You want to write
or-
it down?
Oh.
If you have them there, I can read them off.
That's right.
Okay, just go until your voice goes out.
Okay, all right. We'll see how long. So in a lot of these search and rescue scenarios, they're fires, right? So there's a lot of smoke and low visibility. Have you thought about what to do in that type of case where the camera will be able to see?
We've not specifically thought about that. We initially thought that we would want to mount an infrared camera on the vehicle. It's something that some other military systems do. We thought it might be useful to locate, for example, the heat signature of someone passed out unconscious on the ground. However, there is no current IR system that is within our budget and also usable with the other technology. So that's why we strayed away from that. But no, we don't really have a way to see through smoke right now.
So this is for the scope of, okay. You mentioned sort of the data that comes in as sort of a bottleneck. Is there any way that you might avoid the realism and get sort of not get a full picture, but have some sort of key frames or key things that pinpoints?
We could easily just scale down the resolution,
Yeah.
yes. And it's possible to do that adaptively as well with software, depending on the signal strength that you have available. We've not looked at trying to use software to pick out things on board the UAV and then only send those things down. We're looking into that in the future. But for right now, our plans are basically just downsizing the data that we send in some form or fashion to fit the smaller file.
A comment and a question, if we could. Now, all the team members should be participating in the question and answer, so just because your back is turned doesn't mean you can be anonymous. And if I can follow up, actually with a technical question, follow up on yours, from a perspective of ignorance, all right? Is it possible to transmit data at a low data intensive level as a screening pass? If you find something interesting in the view, then you can intensify the amount of data that's being transferred to get a sharper focus view?
If we were doing streaming over Wi-Fi, where we can send lots of different types of data, yes. If we were using a purpose-built video link, the frame rate and resolution output of the video off of that is limited due to actual hardware limitations.
Okay.
So it depends on the method a little bit, but yes.
Okay.
And that's kind of the adaptive programming also. He was talking about changing the resolution based on what the speed of transmission that you're getting.
Got it.
I have a last one. You touched on a little bit here monoscopic versus stereoscopic. But in your research questions, you say you want a system that is more efficient and more all these things. Is there a way to test what the baseline is in terms of how good a person controlling a UAV without VR or AR can actually perform in scenario? And then, on top of that, how much better your system is compared to that? I mean, I think it would go a long way to
So-
quantifying.
As part of the, could you go back to the simulation slide? There you go. So as part of the simulator, it's very easy to simulate less capable headsets as well as just a flat screen by literally just displaying the same image either at lower resolutions, frame rates on the same VR headset or just displaying it on the screen of a computer. So you can use any combination of input methods and viewing methods with that simulator. That's the different configurations that I talked about. That's what we would intend to do.
Okay.
So that way we can simulate existing systems as well as ours with basically the same hardware.
I think that would be really useful to show.
And also do mention the NIST standardized tests.
Yes, so as I said before, NIST tests, or at NIST sites, testing for UAVs does occur. So by comparing, if we're able to test there, our data against previous data, we can also try to objectively determine which is better.
Just so that it really isn't just the three of you, why don't all of you just stand up and just turn around and form an arc, and that way then, then we can all listen. In the previous question, we related to fire and smoke, we actually have a fire and smoke expert right there. Okay, so if anything could be done inside there, Matt can address that. Just he isn't. So please make sure that all of you do pipe up. They're very, very. I know I'm their mentor, but I feel like they're all very knowledgeable about it, and not just the ones that are doing the talking.
Okay. I will have a smoke question.
Okay.
All right. So one of your goals, one of your aims, your research is to demonstrate or document that the augmented reality and the virtual reality headset interface is a better way to scan a landscape.
Correct.
Is there any reason that wouldn't be applicable with an IR signature versus a video signature?
Right now, we're just focusing on basic AR or VR overlay without the IR because, as Josh mentioned, the current IR systems are not very available, or we can't readily attach it to
But if I
the
bought
UAV.
one, handed it to you, would the same logic hold?
The same logic as the improving the efficiency.
The same logic as to demonstrating whether you could use the headset and the augmented reality and to guide where you're looking and the guide where the heat signature is coming from?
I believe so.
Yes.
Yes.
Okay.
There's also the problem of latency and data though. If you added another additional IR overlay, say, onto your screen, there would be additional data sent, and that could lead to additional latency from the head-mounted display, and that could cause VR sickness.
Now I'm thinking about your company. I mean, your company's gonna be selling these things. You're gonna have a heat special one, a smoke special one, a video optical.
That's Model 2, it costs.
But that's how you're gonna make your money, right? You're gonna sell one to firefighters, you're gonna sell another one to someone else,
Absolutely.
right? That's how you're gonna be successful in this thing. But your proof of concept, from my point of view, it sounds like it could translate all those different operations, right?
Yes.
One final note about the IR. The other reason that they're going to be hard to integrate into the system is they're very resolution limited. The resolution on them is something like 640 by 480, which is equivalent to an old tube TV. So it's a very grainy image, and when you view that on a wide field of view VR headset, you're basically going to be looking at blobs.
Okay. How about microphones? How about sound detection?
So the UAV produces a fair amount of sound itself, and while we could
Yeah,
filter
they're
out
noisy.
some of that noise and isolate it, that may be an option for a future model. However, I don't think that's within the scope of our original idea.
Okay. All right.
So actually, I'm thinking about the baby monitor I have has night vision camera on it. It is not expensive. So is that something, could you think about adapting other technology that is in the range of a GoPro cost that might be able to accomplish your goal? Or do you just want to?
So the camera on your baby monitor requires active illumination. So it would be possible, yes, for us to put one of those on the UAV, but then we would need a gigantic spotlight.
There's no light on it.
No, that there should be a ring of LEDs around
Oh,
the perimeter,
you
but
know.
they're going in infrared, which you
Okay.
can't see.
Gotcha.
But you still need, it's just working in a spectrum. It's a little bit above, but you still need a light source.
Okay. Who, you had someone else want to
What?
I thought you want to say something. Yes.
No.
Okay. Go ahead.
It's kind of around the design. I was wondering about weight load. If you've got two cameras, will it be able to fly just fine with both of them up there?
Yeah.
So they can bear a considerable amount of
Yes.
weight?
Oh, yes.
They come in different sizes.
Okay,
This is just an example of a small one.
okay. And then the other thing was, it sounded like, so the video feeds with the very large rates was for one camera, right? Or is it for both cameras?
The given 7.5
Right.
units per second.
Yes. So
That's for
do you wanna
both
go
of
back to
them?
that slide real quick?
Yes.
So essentially, this is, we would be taking less than the maximum resolution from each camera, because for a VR headset, this is actually two 1080p by 1200 screens.
Okay,
So each camera is taking video at that, or taking video at some higher resolution, getting cut
Mhm.
down.
A practical question. How many Oculus Rift headsets do you have?
There will be one. We're looking at getting one working right now. We're actually waiting for the the consumer version of the Oculus to be released. It was just available for pre-ordering like 2 months ago, and won't be here until March, I believe, is when.
March 28th is the first time they start shipping.
So right now, as a team, we're only going to be focusing on one until we possibly order more.
So what happens if that one breaks?
McKeldin has Oculus Rifts available for rent, which
This
would
is-
be a good
This is
stopgap
the-
if we end up.
But this is
one
the older
generation.
development model. It's not the one that was released for consumers, but I'm assuming they'll get the consumer versions at some point. So.
You might as well tell them that
Yeah.
some of them intend to acquire and are in the process of acquiring a personal one, and the lab will be acquiring one, so that does not give them the license to break them, but it does allow them to research actually another part, which is collaboratively looking at it. So, then two people could be looking at the same thing, although one would have to play as the person that is actually is directing the actual camera. So that's yet another thread which we have not talked about, nor with this thing, there's enough scope in here for
I have two questions. One's a very practical question, and one's more of a research design question. Which one do you want first?
Let's go with the research design.
All right, research. You've made a lot of references to go see what is better, see how it performs better, see how things are optimized or more efficient, or terms like that. Quantitatively, how are you going to do that? How are you going to demonstrate on a quantitative basis and a replicable quantitative basis that your ideas and your conclusions are solid?
So one idea we had was for the flight simulator, we were going to have a set course of waypoints that were going to be randomly chosen in the order for each user. They would fly through the course and try to navigate as close to the waypoints as they could. Once they do that, we would measure how close they got to the waypoints, what time it took to complete the course, probably time in between waypoints also. That's one test for that specific thing. Also, for Xinjiang's test with the depth,
The stereoscopic purity test.
do you want to talk about that?
Go back to the kid. So it's hard to see, but basically in this test, what they see is the bottom video here. And when they try to line up, they hit a button, and a number will be displayed there that will tell you how close they were. And if we compare the number in monoscopic versus the number in stereoscopic, hopefully, we hypothesize that in stereoscopic, the number will, or the two objects they align will be much closer.
And then it will be replicable over users
Yes.
in different tests, and all those people will be your team members?
And maybe if IRB approved,
That's where I was going. But you're on that path.
yes.
That's very good. All right, great. Because you really have to have that research question, and you really have to generate some quantitative data with a a technical design like this, obviously you need that quantitative database to say yes, you hit it, or you missed it, one or the other. Okay, now the practical question, what's more range limiting, the mechanical quadricopter or the distance you can transmit data?
The distance we can transmit data would be more range limiting.
How far do you think that's gonna be?
That is actually a great question, which we are going to be testing with the GoPro tests this coming few weeks.
Okay, so if you find over the next couple of weeks that your range is 100 meters, what's that gonna do to your hypothesis?
Well, for now, we don't have the optimal antenna that we would be using for our panel model. We were proposing that we were going to have a circular polarized antenna on the UAV, which we don't have currently, to transmit data from the GoPro. And furthermore, we don't have the directional antenna that we would be using on the ground control station. So hopefully with the addition of those two antenna, our project will be more successful and the testing will reveal immediately.
Okay, I got it. So that's a big unknown for the applicability.
The purpose-built HD video links have tested ranges, obviously, from the manufacturer. So those, if we were going to use one of those, we would know more or less what range it at least should get or get close to.
Mm-hmm.
But with a Wi-Fi system, it's anyone's guess.
Okay. And I suspect in a disaster search and rescue, the Wi-Fi signal would be down.
Well, this is a system. So you have essentially one router on the UAV, one router in your ground
Okay.
station. So you're operating over your own link. You're not relying on
Got it.
anyone else.
All right. You have something?
So as a team, I imagine you all have some sub-teams. How will you all organize and hold each other accountable throughout the next 2.5 years?
Well, so far we've been rotating sub-teams based on like what we want to do and creating like small milestones, so we haven't had like set sub-teams. But like the way we hold each other accountable is we create a like collective set of goals and we set a deadline for it. If you don't meet the deadline, then we make a mark against you, and if you keep accumulating those marks, then we'll report you to Dr. Dean, and Dr. Dean will deal with that in his.
We also
Either way.
have a designated ombudsman for solving inter-team conflicts.
That's important. Yeah,
But-
next exams are in this hot room with bright light. I like this.
Also on our Google Drive, we have a team constitution.
Oh, very good. Okay. I have one or two more. If anyone else, any more questions?
One.
Okay. go ahead.
In here, it says February 2016, apply for grants. What kind of grants are you applying
Thank you. That's my
Oh,
question.
Good.
So, to be negative, we have a grants team, and we're currently working on applying for grants. We've pinpointed several that we would like to apply to. One being, a lot of them are ones that are directed more towards research in like schools and in colleges. What we want to apply for specific is there's like
Sloan
this.
Foundation.
There's Sloan Foundation. There's the Spencer. Offers a lot of grants for research in undergraduate, like.
And the library, Gemstone Library Award.
So yeah, I've applied for that.
Have you investigated federal funding?
Yes, so I did a lot of looking into federal funding over the winter break. So what I found was that a lot of federal funding is intended for projects that are a lot larger than ours and have a lot larger scale. So either we fall outside the scope of those grants, or I don't think they would like even consider us like within like the areas of their funding. But I mean, we could apply, but at this point, I think it's a little bit of a waste of time, considering
It's better
that
to
there's
target the small
the more
ones.
feasible grants, and also some of those grants give out like $100,000 rewards. We really don't need. I mean, it would be nice, but we really don't need that kind of money.
Okay, so you need, what, 8,000, whatever the slide says, something like that. Which is a different number than in your proposal
Yes.
document, but that one's a little bit larger. I guess it grew over the last week and a half. That's fine. So, I mean, you need that. I like the detail of your outline. Looks good. So, what if those grants don't come through? What are you? Where's $9,830 coming from?
Can you give me?
So a large part of our project is actually developing the AR and VR interfaces. The most of the cost, well, actually all the cost that's outlined there is for the physical prototype that we have planned. Supposedly, we can create software that would simulate our design and to test whether or not it's actually an improvement over current methods of search and rescue, even if we don't get to build a prototype.
Okay.
You might consider reaching out to local industry companies or businesses and saying, hey, we're an undergraduate team. Could you donate money or supplies or something like that? A lot of them are probably fair loans.
And also, have you thought about reaching out to associations of first responders?
We have not.
That's a good idea, though. We will look into it.
But I think there's a larger question, and it's not just about getting the grants. I think what was asked is, supposing you don't get all the equipment that you need, what is the off-ramp strategy? Okay, and so that should fit in with your research questions. How much of you can? You should have a clear idea. We can or cannot answer, say, for example, one thing could be, we could answer question number 1, but we couldn't answer we could do half of question number 2, we could do none of question number 3. That's the kind of articulated off-ramp project plan that you should have. And I don't think we've really talked about that. And I think it's a very good question as to, well, what happens if, if we get a lot of funding, then what happens if you get triple the amount or the 100,000 rand? Well, what is that's a positive off-ramp.
Then we build X number of prototypes.
My point is this needs to be thought out at some point, not necessarily now, but at some point it needs to be thought out, both up and down.
And your research design, your project design is multifaceted, and there's several possible ultimate deliverables along the way, which are all research successes, if done rigorously and done completely. Yes, having a thing fly over a standard course at NIST is a wonderful thing to strive for, and it will be the cherry on top of the sundae. But the idea of proving that your technology concept, which is really the original thought that you have here, can work is a very good deliverable.
You might want to think about milestones as this is my baseline success, my moderate success, and then our reach goal. What we want to do.
Other questions?
So as you're thinking about the grants, just to make sure you know to plan out the time to route all the forms through Dr. Dean and his department, so that you don't miss your deadlines. I think often with Gemstone students, not necessarily you all, but any Gemstone student sees the deadline of March 15th and thinks that we have another 3 weeks, but really we've already missed that deadline for any external funding. So be sure you're planning ahead, and that's anything that's external to the university has to be routed through the Aura office.
So if you try to hit a deadline, make sure you're ready to go a month ahead of time.
And we can route some things through Gemstone, though it is usually much faster to go through.
Yeah, that's what I was gonna ask, is, do Gemstone projects route their proposals through Gemstone or through their units?
It's much more efficient if you run through the mentors.
That's what I wanted to ask,
Yeah.
yeah, because it's straightforward from us.
And then
Right.
you can
Okay.
get the credit for it too.
The College of Undergraduate Studies has no mechanism in place.
Yeah,
Because it-
Good,
It's
that
foreign,
was actually, we had a small discussion about this point, and so I'm
Yeah.
glad.
But let us know everything you get, because we like to brag on you. Anything else?
What UAV are you gonna get?
So, we don't know, is the short answer. The better answer is probably something about twice this size. So,
How are you gonna decide which one to get? Is it kind of do you have a list of preferred, like, you've seen all of them, and so now you've got a list of like which ones you want?
the UAV that we will probably be building as a prototype is much better described as an assembly of parts rather than a unit that you have to pick which one you want. So various goals that we have will dictate which specific components we choose. For example, as we start building up this gimbal system, the weight of that final system will dictate how large the power system on the UAV needs to be in order to lift itself plus the payload, which will dictate how large the frame needs to be, which will dictate how many other components we can put on it, et cetera, et cetera.
Okay.
So it'll be sort of kind of a snowball process in terms of how all that's figured out.
There is a, we have, we had connected with the UAS test site. University of Maryland has a test site now, and they have, they've even, talked about, we'll do a flight test there, later this semester. But they have other drones that they are willing to make available. So in fact, the path that they all will follow will be a sequence of learning steps with more sophisticated, and more sophisticated, but also capable of carrying larger payloads. And so that will build the knowledge base in order to arrive at what Josh was saying, the sort of final unit. There's several practice systems that can be built.
Additionally, to test the actual payload, we don't actually need to have it flying. You can just hold it and test it by looking around. So worst case, we can even test the final payload just in the lab.
Okay.
Okay. Finally, do you all have any questions for us that you would like to ask?
Well, I suppose money was one thing. We do need to buy an Oculus Rift at some point in the future. Does anyone know more about it in terms of cost and what we need among my team?
It's $600 without, or just without the taxes alone.
It's about $700 with shipping and taxes.
Cool.
So, the one of the founders is in Maryland.
Yeah.
And he's paying for a nice building. It's seeing your way or Parkinson's. Has anyone tried reaching out to the company through, some of our business operations folks to see if they might be willing to donate some for research?
Well, that seems like a good step.
Yeah, that seems like a very good idea.
We should be careful with that one, to make sure we go through.
Well,
the-
go through. You wanna go through?
Yeah.
your
Which is
business
what
folks?
I've been suggesting, that yes, we need to go through the VPR's office and things.
Yeah,
So
so
we
like,
wanna make sure
Becca
that give
Kier
some things.
in mechanical and aero, she deals with business, folks.
And you probably have your person too, right?
Oh, yeah, no, and also the VPR's office itself, I deal with them time to time directly. But you don't wanna bother the large corporation with small stuff. So they could give us a building and it has some gear, that's fine. But for the needs of this, the commercial track is just fine up until the time that it rises to some level which deserves another building and and that's what. So they've already contributed something to the university and things. So we will fold. So the intention is to fold this group into that effort at some point, but without, but being mindful of that it's not seen as a small thing out there.
But I don't see any harm in asking our VPR folks.
No,
As
that's
opposed to,
no, we do want to do that. Yeah.
It might also be worth asking, McKeldin, I imagine, is buying some new ones to rent out, and I bet even the makerspace in engineering may have some, so it might be worth coordinating, asking, if they're getting some kind of bulk discount rate for the number that we might be purchasing at the university, to see if we can add one more in, might get a little bit of a discount, and then your $600 that you have access to right now might cover that.
I'm wondering if, thinking about the bulk purchasing, I know a lot of times you've got your institutional purchasing, and then as you're an individual, I'm wondering if they can't slide in under the institutional with that group, maybe they can slide in under some other kind of, we are part
They should
of
save the
this.
sales tax.
Oh,
Nothing
yeah,
else.
you won't be paying any of the tax.
Or just get a loan from the library, the gears, loan, for.
If they're getting new
Figure out
ones
more.
and they know that they have a team of students who's eager to use it, as soon as it arrives, you can be the one who gets it out of the box.
Okay, so these are great suggestions. We will definitely solve them.
Definitely have a lot of options.
Okay, well, I think this is the kind of what we used to call the jumping off point, but we don't use that term anymore. But this is where you focus on moving forward through your research plan, through the trial and error process that is research, and you will let us know what we can do to support you on your way. And I think you're at a good place and at a good starting point, so charge ahead. Well done.
And I mentioned to Jin Chen when I started, we are uploading some of the videos to YouTube, but I'm wondering if you want us to not upload yours, if you might pursue some kind of technology transfer.
We discussed this among ourselves a bit. I think we said it's fine.
It's fine.
But
Fine.
yeah.
Alright.
And also unrelated, I've been getting little notices that there's a dangerous storm approaching, so
Yeah.
you may want to stay inside for a little bit now, even though we're done a little bit early.
Quick, it's an opportunity for disaster, so.
Seriously,
Get out of this
let's
safe basement and get outside.
Get the drone outside.
That's right.
And you all are gonna put the room back together anyway, so you're
Yeah.
just wait for a little
Yeah,
bit.
well done.
Yes, good job.
Thank you.
Thank you.
Thank you very much. Thank you.